Good evening. This evening we have session 4, Weather and Climate, and it is presented by Miss Delor Davis.
Good evening, Prynhawn Da, and welcome to the fourth and final session for GCSE Geography. Today we're going to look at theme 5, which you would have studied in year 11, which is weather and climate. First up, 5.1.1, climate change during the Quaternary period. So what is the Quaternary period? It is the current and most recent geological time period. It covers from 2.6 million years ago to the present day. And during the Quaternary period, the climate has changed drastically. We've gone through glacial periods, and we've also gone through interglacial periods. And scientists have said that the ice has retreated, which is interglacial and advanced glacial periods, over 60 times within the last 2.6 million years ago. Therefore, climate has varied greatly over this time. Here we have a graph showing the global temperature trends from 400,000 years ago to today. Now, this dotted black line across the screen shows the temperature at 0 degrees, which is freezing point. Anything under that, which is shaded blue here, is the glacial periods. And anything above that, the pinky red colour, is in the interglacial warmer periods. As you can see, we are clearly in an interglacial period. The Wales and the United Kingdom is not covered in ice. The temperatures are much higher than 0 degrees, so we are in an interglacial period. So here we have a map showing the ice coverage in glacial times, which we've got here on the left. And as you can see, the ice has advanced quite south, nearer to the equator. So the equator is at 0 degrees. It has advanced from the poles closer to the equator. So you can see here, Northern Europe is covered, United Kingdom. It's not a very good geographical map, but North America is covered in ice. And on the bottom here is ice coverage today. As you can see, only in the high latitude areas that we see this coverage of ice where it is cold throughout the year. So we are in an interglacial period. So what is the evidence that our climate has changed? For example, 2.6 million years ago, and that graph I showed you of 400,000 years ago, is a long time ago when there was no technology to measure the temperature. So how do we know this? So now we're going to go through the evidence for climate change. So first up is thermometer reading, but this only goes back to around 1850, 1870, the end of the 19th century. So, ongoing temperature recordings using thermometers have shown a clear warming of the Earth's temperature over the past few decades. By using this data, scientists have seen an average combined land and ocean surface temperature increase of 0.85 degrees since the end of the 19th century. Now, at the end of the 19th century, we saw the Industrial Revolution, and the burning of fossil fuels began at a larger scale, and the population also exploded since then. So the demand on our Earth has definitely been increased and has led to the rise in temperature. Another evidence of climate change is glacier retreat. So here we have on the screen here, on the left, glacier in Peru from 1941 and 2004. And as you can see, the ice has retreated a large distance over this time. Okay, I've remembered myself going on holiday to New Zealand as a child in 2002, and in 2014 as an adult, and I went to the same glacier First time I could go and hike to Franz Josef Glacier, but by the second time I arrived 12 years later, you had to have a helicopter and drop you off because the glacier has retreated so much. Okay, another evidence for climate change are ice cores. Now, when snow falls, it traps air into the ice. When scientists take a core of ice, it reveals the carbon dioxide and methane concentration at the time the snow fell. Scientists believe that there's a close link between the amount of these greenhouse gases trapped in the ice in the atmosphere and global temperatures. This has enabled scientists to look thousands of years back into the carbon dioxide levels in the atmosphere then, which was trapped in the bubbles in the ice. Another evidence for climate change is extreme weather. It is expected here in Wales and the UK that during winter we'll get more extreme weather, so extreme rainfall, extreme temperatures. And some areas in the summer will have higher pressures for longer, which will cause drought. So we are going to see a much more extreme weather in the future due to climate change. So the frequency of extreme weather events have increased. Okay, so here we have a graph which shows the link between the carbon dioxide, which is the purple line, with the global temperatures, which are the green line. So the question on the screen is asking, what does this graph show? What is the trend? Now, this is a classic, geography question when you've got to describe the pattern in the graph. Remember, if any question asks you to describe the trend in the graph, you must include figures from the graph to support your description. So the general trend here is this. As the levels of carbon dioxide have increased since 1880, the temperatures have also increased. But having said that, you can see that the temperatures have fluctuated over this time, but the general trend that it is increasing. And you will also need to include data. So for example, you could say that the carbon dioxide was around 295 parts per million in 1880, but this has increased to around 380 parts per million in CO2. That is a difference of 100 parts per million over a period of 140 years, something like that, okay? Right, another recent evidence of climate change includes higher levels of carbon dioxide in the atmosphere, and this has been more, proven and this data has been collected since technology has allowed us to since the 60s. So we've seen higher levels of carbon dioxide in the atmosphere. And temperatures have increased 0.6 degrees in the last 100 years. Now, this graph on the screen is quite a famous graph. It's called the Keeling graph. So a Keeling graph shows the increase in temperature and the link with CO2 levels, therefore providing evidence that global warming is occurring. Monitoring started in Hawaii in 1958 in the middle of the Pacific Ocean, and where there's not much industry there. So it's a true representation of the carbon dioxide levels since the 60s. And as you can see, it has increased tremendously, but this is due to anthropogenic or human factors, such as deforestation and burning of fossil fuels, things we'll go into in a bit now. As you can see, okay, it has fluctuated during the year. You must take into account seasonal there, in the summer you may have more vegetation growth and more photosynthesis, so it may be lower in the summer, higher in the winter, etc. Okay. Another evidence for climate change is the study of tree rings, or dendrochronology, okay, or tree rings. Tree growth rings are added each year the tree is growing. These rings are recording the growing season, and the thicker the ring, the better the growing season, because it may be much more rain, which enabled it to grow well that year. So that's a good indication of temperature and CO2 levels, which is connected to it, tree rings. Okay, so that's it, the evidence for climate change. Now we're going to look at what are the natural causes of climate change. Okay, one natural cause of climate change that may explain why the Earth has gone from glacial to interglacial periods and back and forth again, and we may very well be due to go into another glacial period before long, is the Milankovitch cycle. So Milankovitch, the scientist, suggested that the Earth is going through warmer and colder phases naturally. How? Well, the Earth wobbles on its axis every 26,000 years as it orbits the Sun, which affects the energy it receives from the Sun. So if it's a bit further away from the Sun, then we'll go to a glacial period. The tilt of the Earth, because the Earth has tilted, I think scientists say is due to a collision with another planet years ago. That's what they say anyway. So the Earth is on its tilt, and it varies between 22.2 and 24.5 degrees every 41,000 years. So that's a difference of around 2.3 degrees in a difference in tilt. And this also affects the energy it receives from the Sun. So the greater the tilt of the Earth, the more solar energy the poles receive, which means we'll be in an interglacial period. Okay, so that's one natural cause to explain the changes in our climate. Another natural cause for our changing climate is the greenhouse effect. Now, I want to emphasize that the greenhouse effect is a natural process. I'm just going to read the screen. The atmosphere traps some of the heat that is reflected from the Earth's surface. This is known as the greenhouse effect. Without this natural process, temperatures would be much colder on Earth. Without naturally occurring greenhouse gases, the Earth's average temperature would be -18 degrees instead of the much warmer 15 degrees. So the Earth is only livable due to the greenhouse effect. So I must emphasize that it is the greenhouse effect is a natural causation to our climate, warm climate, but what we are seeing is the accelerated greenhouse effect. I'll go into that in a second now, but I just want to go into the greenhouse effect. So here we have a bit of a diagram here. So some solar radiation is reflected by the Earth and the atmosphere, but most radiation is absorbed by the Earth and warms the Earth's surface. Okay, some of the infrared radiation passes through the atmosphere. Some is absorbed by greenhouse gases in the atmosphere and re-emitted in all directions by greenhouse gas molecules. The effect of this is to warm the Earth's surface and the lower atmosphere. Okay, so that's the natural greenhouse effect. Another natural cause to our changing climate is volcanic activity. Now, volcanic activity doesn't make the Earth warmer, it actually leads to global cooling. Okay, so as a volcano erupts, ash and gases are released to the atmosphere. The sulfur from the gas that's erupted out, the sulfur combines with the water vapor in the stratosphere to form dense, thick clouds of tiny sulfuric acid droplets. These droplets absorb the incoming solar energy and it reflects it back into space. So these thick clouds restricts the solar energy from coming into the Earth, and the temperature of the Earth cools due to a volcanic activity. Now, I must stress that this event is quite rare, okay? And the most recent example is this back in 1991, which is Mount Pinatubo. Pinatubo is a volcano in the Philippines. Now, before Mount Pinatubo, one of the last examples of global cooling due to volcanic activity was Krakatoa back in 1883. So this is quite rare, and it doesn't have a big impact on long-term climate change. So, case study, Mount Pinatubo. Over the course of several eruptions, a massive 10 cubic kilometers of material was ejected, making it the second biggest eruption of the 20th century. So Pinatubo injected about 15 million tons of sulfur dioxide in the stratosphere. Sulfur dioxide reacted with water to form a hazy layer of aerosol particles. Strong stratospheric winds spread these aerosol particles around the globe, and data collected showed that the mean world temperatures decreased by about 1 degree over the 2 years following the eruption. You might think, oh, 1 degree isn't a lot, but it does have a massive impact on agriculture and growing seasons and crops, which may then lead to things like famine or poverty. Okay, here we have now looked at natural causes for global climate change. Now we're going to look at the human factors, and these are things that are on the news and the media all the time. So one activity, human activity, is burning fossil fuels, for example, coal, gas and oil. These release carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas, so if there's more carbon dioxide in the atmosphere, they absorb the solar energy, and that heat doesn't get released back into the atmosphere. Deforestation. Trees absorb carbon dioxide during photosynthesis. If they are cut down, there will be higher amounts of carbon dioxide in the atmosphere. Dumping waste in landfill. Where waste decomposes, it produces methane, which is a very strong greenhouse gas. Lot stronger than carbon dioxide. And agriculture, some unsustainable practices lead to the release of nitrogen oxide in the atmosphere. So they are the 4 human factors causing climate change. Now, one thing I'd like to just recap is this, the greenhouse effect. Now remember, the greenhouse effect, without the greenhouse effect, the temperatures of the Earth would be around -17, -15 degrees. But it's on this average 15 degrees due to the climate change, greenhouse effect. But what we are seeing is the human enhanced accelerated greenhouse effect. The rise in population, deforestation, burning fossil fuels, etc. all leads to more and more greenhouse gases being released into the atmosphere, which is absorbed by the sun's energy, okay, making the Earth warmer. Okay, now we're going to look at the UK weather and climate. So we've already looked at the evidence for climate change. We've also looked at some human and physical causes of climate change. Now we're going to look at the weather and climate in the UK. Okay, so on the left here, I've got the weather forecast for this week for Haverfordwest in Pembrokeshire, and on the right, I've got climate. So the question I've got now is, what is the difference between weather and climate? Well, the weather is the state of the air and atmosphere day to day. For example, it's windy and rainy today, it's sunny tomorrow, okay? Weather can change hour to hour, it can change day to day. The climate is the, weather with an E, weather conditions in an area over a longer period of time. Now on the diagram on the right there, on the map, you can see large scale climate patterns that we have got on the Earth. So we are in a temperate climate zone. Because we've got a temperate, it means that we're not too wet, but we're not too dry. We're also not too cold, but it's not too warm. It's quite mild, okay? So we've also got 4 seasons in a year: winter, summer, spring and autumn. So we are in a temperate climate zone. Now, you've also got polar, which is the cold and mostly dry, which is the furthest away from the equator, the higher latitudes. You've got the arid, where you've got high pressure air. For example, the Sahel region in Northern Africa and Australia, mainland Australia. And for example, you've also got Mediterranean, which is the Southern Europe, which is, you've got your winter and summer seasons, but it's also very warm in the summer. And you've also got the tropical. Tropical are along the equator, which is very, very wet, but also very warm, and it doesn't really have any seasons, okay? So weather changes day to day. Climate is the weather conditions over very long periods. Now, the weather is shown using synoptic charts, which is weather map, with official symbols to show the conditions of the atmosphere at specific weather stations. So here are the things shown on a weather map, which is a synoptic chart. They measure they tell you the temperature at that particular location, the precipitation, which means rainfall, snow, hail, etc., the direction and the speed of the wind, and also cloud coverage. Okay, and also pressure as well. They're all the things shown on a synoptic map, as you can see on the screen on the right. Here we have as well isobars. So isobars are those lines showing air pressure, and along the line, the pressure, it links air pressure of the same value. Okay, right. So firstly, we're going to look at maybe more global scale impact on our climate, which is the role of latitude. The yellow line on the map there is the equator, which is 0 degrees latitude. So remember, the latitude measures the distance of a place north or south of the Earth's equator. For example, the United Kingdom is between 50 and 60 degrees north of the equator. Okay, the polar regions are around 80 degrees north of the equator. Now, this is some sort of heat map where the darker the red, the warmer the temperature. Now, as you can see, the warmer temperatures are found along the equator. And the further you go away from the equator, so the higher in latitude you go, the colder the temperature gets. So why? Here we have here a diagram. Okay, now the area of the equator receives the most energy from the sun. But why? Well, first up, the sun is at a lower angle, and it's at a lower angle to the equator, and it's a much more concentrated there, and also it's got less of the atmosphere to go through. So let's have a look here. Temperatures drop the further an area is from the equator due to the curvature of the Earth. In areas closer to the poles, to high latitudes, sunlight has a larger area of atmosphere to pass through, and the sun is at a lower angle in the sky. As a result, more energy is lost and temperatures are cooler. But remember, the Earth, as I told you earlier, the Earth has tilted. Okay, now in our summer months, which is June, July, August, the northern hemisphere has tilted towards the sun, So that's why we get the seasons. So that's when we are warmer, because we get more of the sun's energy. But during, December, January, February, the northern hemisphere tilts away from the sun, which means that we get less of the Earth's energy, and that's why the temperatures drop. Now, the areas along the equator, regardless of what the tilt of the Earth is, always receives the most of the sun's energy. That's why it's warm throughout the year, and they don't get seasons. Okay, so let's have a look at the UK specific now. Now, here we've got a map of the UK, and as you can see on the left, right, the south of England there, by Cornwall, they are at a latitude of 50 degrees north. North of Scotland here, I can see the Orkney Islands are around 59 degrees north. That's a 10-degree difference. So northern Scotland is 10 degrees further away from the sun, from the equator, okay, which affects the percentage of the Earth's sun's energy receives. So what difference does the latitude makes to the UK's climate? Well, here we have the temperature for the UK in winter, okay, and as you can see, northern Scotland here is colder. They've got around 4-5 degrees in comparison to around 7 degrees in the south of the United Kingdom. Okay, and at the top here, quite small, sorry, the reverse, as you can see, the summer, the southern England, there's 17 degrees, whilst it's 4 degrees colder, 10 degrees latitude to north in northern Scotland. But that's not the only thing that impacts the temperature in the United Kingdom. One thing that influences this is distance from the sea. Now, oceans heat up and cool down much more slowly than land. This means that coastal locations tend to be cooler in summer and warmer in winter than places inland at the same latitude. Glasgow, for example, is at a similar latitude to Moscow in Russia, but is much milder, warmer in winter because it's nearer to the coast than Moscow. Okay, have you ever been on holiday and you've gone from the sun lounger onto the patio or the ground, and it's so hot you can barely stand on it? But that's because the land heats up like that, but it also loses its warmth straight away. So that's why inland areas are warmer in summer, but colder in summer in comparison to oceans. Okay, here we got lines there showing temperatures are higher in the west and along coastlines. Okay, here we have the opposite now, UK temperatures in summer. Now, isotherm there, lines that connect places with the same temperature. And as you can see, the highest is around London and southeast England. And the coldest are in northern Scotland due to the role of latitude. But it's not just that. Another thing that here is also distance from the sea. So, like I said, in the summer, inland areas warm up straight away. So as you can see here, the inland areas then in England are warmer in summer. Okay, another thing that affects the coastal areas is the ocean currents. The North Atlantic Drift or Gulf Stream ocean current flows northwards across the Atlantic Ocean, bringing warm water from the Gulf of Mexico. This results in milder winter temperatures in the west of the UK. Because it's warm, that means there's more evaporation, which means more rain. And that explains why we've got warmer but rainier climate in the UK. Another factor that influences our climate is the prevailing winds and air masses. So prevailing winds in the UK blow from the southwest across the Atlantic Ocean. This brings warm, moist air, which helps produce the mild and wet winter. So wind that blows over sea picks up moisture, so brings rain. The west side of the UK gets more rainfall, mainly frontal and relief rain, than the east, which is in the rain shadow of the higher land of the west coast. Air masses. Although the prevailing wind is from the southwest, there are 4 directions from which air travels to the UK. Each wind direction brings different climate conditions, okay? So our weather is also dependent on where the air masses come from. More often than not, our weather is tropical maritime. Maritime because it's blown over the wind and the sea and picks up moisture, and also it can be a bit milder. Okay, so the United Kingdom has a temperate maritime climate. Now, here we have a map which has Plymouth, Prague, which are on 50 degrees latitude, and Orkney and Helsinki, quite close to 60 degrees latitude. Now, as you can see from the data here, Plymouth is 6 degrees in January and 16 degrees in July. Now, Prague, which is on the same latitude, which you'd think, ooh, same kind of climate, is -2 in January and 17 degrees in July. Now, the reason being, even though they're on the same latitude, Prague is in the inland, nowhere near coast, which means it heats up quickly during the summer, but it also loses its heat in winter. So that's why it explains why it's cold. Also, Plymouth and Orkney are affected by the North Atlantic Drift, bringing a bit warmer waters. Okay. Right, this is the effect of altitude in height. So have you ever climbed a mountain and find yourself cold at the top but warm at the bottom? Well, temperature decreases 1 degree for each 100 meters climbed in height. But I want to stress that this is very much a local effect on climate, and this doesn't affect the whole country's climate. It only affects the climate in a very local area. So that's the effect of altitude. So Ben Nevis, there's difference between at the top of Ben Nevis, highest mountain in the UK, and sea level is 10 degrees. Okay. Another local effect on climate is the effect of, it shouldn't say altitude there. If it's the slope is north facing or south facing. So if it's south facing, it receives much more sunlight than north facing. Sorry, that should say aspect. So aspect is the direction in which place is facing. Aspect only really affects local climate. In the northern hemisphere, south facing slopes receive much more sunlight than the north facing ones, therefore are better for agriculture, and often settlement will locate there to the better aspect. If you're wanting to buy a house or trying to sell your house, if it's south facing windows, that's a good selling point. It all to do with how the sun rises in the day. So how much does altitude and aspect affect the rainfall? Altitude affect the rainfall pattern in the UK. Here we have a graph where the darker blue here shows over 2,000 millimeters in rainfall annually. And as you can see, the west of the United Kingdom gets the most rain. But why? Okay, so the highest rainfall is seen on the high ground mountainous region, because this is quite a mountainous area. And remember, rain is coming from the southwest, hits high areas and are forced upwards. And when air is forced upwards, it means it gets cooler, condenses to form clouds, which bring rain. And just going to recap this quickly. So how does it rain? Moist, warm air and water vapor rises. Air is cooled as it rises. Condensation occurs, which form clouds, and you've got precipitation. So that's just the basics here. So this is what I meant. This is why the west of the UK gets greater rainfall. Relief rainfall occurs when warm, moist air crosses, from the Atlantic Ocean, rises over days, and that brings rain. And on the other side of the mountain, you do get drier conditions, known as a rain shadow, because the air then sinks, bringing in more stable weather and less rain. Okay. I'll go through this very quickly. Here we have an example of an exam question where you've got annual rainfall, and the darker the blue, the higher the rainfall. So the question here says, use the key to give the rainfall total at place A. So here we have place A, and that is this middle blue colour here. And you look at the key, and as you can see, that matches this second one, that same blue. So that area, place A, gets between 750 and 1,250 millimetres of rain. But question 2 is, use information in the photographs to help you describe the difference in relief of the land between northwest Wales and eastern England. So this picture here is near X, and then you've got Y. Well, as you can see, the relief of the rainfall here, the shape of the land is quite mountainous, highland, mountainous, in comparison to very flat land here in eastern England. Now, the northwest of England would receive much more rain due to relief rainfall. Right, so briefly, I'll go through this. There's got a bit of a time issue here. So weather associated with patterns of low and high pressure in the United Kingdom. I know you know this, but I'm just going to recap. When hot air rises, you've got low pressure on the ground. Weather associated with low pressure is rain, because when hot air rises, it cools, condenses, and forms clouds. On the other hand, where you've got high pressure, you've got sunny, clear sky kind of weather. Because when you've got hot air and it sinks, it then, as you've got cold air, it sinks, but as it sinks, it gets warmer, you've got any kind of condensation evaporates, and you've got clear sky. In the UK, we get a lot of low pressure during winter times, and you've also got high pressure occasionally. I don't have time to go through this now, but this presentation will be on the online where you can have a look. So in this slide here, I've explained depression, which is low weather systems in the UK, and the weather connected to depressions, and how a depression is formed, and the weather, you see 5 steps in weather. And we'll also as well, or that's how it looks on a map, a synoptic map. I've also here got slides showing high pressure systems in the UK and what it looks like. There we've got satellite images there. And the summer anticyclone and the winter anticyclone. You've got all this online, and microclimate. Just before we finish, I just want to go through this following slide, which is top tips for success, because I know you must have much, well, after Easter, you'll have plenty of assessments in order for your teacher to determine your final grades. So I just want to go over this slide, which is top tips for success in geography. So exam techniques is crucial to success. Think about the following basic rules. Read and follow instructions carefully. I've lost count how many times pupils skip a question because they haven't seen it. Study the resources and use evidence from them effectively in your answer. For example, if the question says, use figure X to describe this, please use that figure and say, figure X shows this. As you can see in figure X, you can see this. So refer to the figure often. That could be a picture, it could be a graph, it could be a map. Understand the meaning of command words. Okay, if you've got a describe question, don't explain why, you just describe the pattern that you see. Identify the key terms in a question. Use these to plan your answer. Answer in sufficient detail and depth. Be guided by the marks available for the question. If you've got a 4 marker, make sure you try and hit those 4 markers. If you've only written 1 line and it's a 4 marker, you haven't had 4 marks, okay? Make sure that you think, oh yeah, I've hit 4 marks there. Elaborate and develop your points. Use geographical terminology. Be able to draw good sketch maps and diagrams, particularly in physical geography, like Unit 1. And manage your time to ensure that you complete all questions the same standard. Okay, and here I've got just a quick slide saying the difference between describe and explain, the 2 most commonly used command words, but it's the one that the pupils mix the most. Okay, describe, just write what you see. You may be asked to describe a photograph, map or graph. Okay, and explain or give reasons for these questions, test your knowledge and understanding. You are being asked to say why something you may have already described is happening. And I'm just going to leave it there. Our time has come to an end. Best of luck in your assessments now after Easter. You'll do greatly. And diolch yn fawr. Thank you very much for tuning in for these last 4 sessions. Diolch yn fawr.